Okay, so some of you may have seen that some stuff is happening this month. Today is the 17th of December. I'm expecting a new mill in the 19th of December. I just got the phase converter for that delivered 10 minutes ago. Okay, so I sold my Tormach. Tormach is a single phase machine. I sold it, it's out of the shop. I don't have any mill in here right now. So what am I getting? Well, you'll see what I'm getting when I get it. I'm not gonna tell you, that's gonna be a bit of a surprise. It's probably in the thumbnail of the video, let's be real. I'm getting a Fanic Robo Drill, an 04, it's got pretty low hours on it, and by low hours I mean like 10,000. For 20 years old, 10,000 hours is low. Especially considering those machines have a lifetime of probably like 30,000 hours, and it might have a replaced spindle. I'm not sure on that yet. I'm excited to get it, but it is three-phase. And so how do we do that? What is three-phase? Why do you need three-phase? I bought my previous phase converter, which you can see here. I bought that new. That is a, what's the kVA on this? It's a 5.6 kVA converter. Hello, I'm back. So that motor is I believe a 15 kVA. It's not actually on the motor itself. It's an 18 kW. I'm not sure how that converts to kVA. I know the mill I'm getting is an 11 kVA mill. You want to over-spec your motors. So I need probably a 15 horsepower phase converter for my mill. I got a 25 because that was what was available at the time, and that is also kind of where you want it over-spec. Everything I looked at said I probably wanted for phase converters a 25 to 30 horsepower phase converter, whereas the mill spindle is only 10 horsepower. And so like a 15 plus coolant pumps and stuff like that probably would have been plenty. So be it. I bought a more expensive, well, I got it used and there wasn't a 20 available used. The previous owner was using a 20, so I was looking to get a 20, but the used cost of the 25 was actually cheaper than the new cost of the 20 by a few $100s. And so I was like, well, I'll go with that one. After shipping, they were pretty similar because I had to get this freighted from Minnesota, I think. And so that was like $400 or $500 to get this shipped because it's a 300-pound unit. It's not small. The motor is enormous. Like you look at that motor and I can pick that up with my hands. I just got my phase converter in like 20 minutes ago, so I'm gonna start working on that. I did have to get a three-phase machine. I am residential, so I have to convert phases. You can actually see a phase converter behind me for the surface grinder. I hate phase converters. They're inefficient and expensive to both buy and run. You take what should be a very efficient form of energy, three-phase, and have to convert two-phase into three-phase through an inefficient means. Heating up my shop, when that runs, my shop gets nice and toasty, and it's Florida, so it's not like I need heat. And the other one's a 25 horsepower phase converter. That's a 5 horsepower phase converter, so it's 5 times bigger. And it's expensive to run. That's going on an 80 amp breaker for what's going to be a 30 amp three-phase machine. Inefficient. I don't like it. That is, I think, on a 40 amp breaker or something like that, and that's 5. And so thankfully it doesn't scale. Thankfully it's not 5 times more energy, but it's not much better. And so very inefficient. I don't like it. They're expensive phase converters. To buy the phase converter, I bought new. I bought it used, so I got a good discount. Would have been like $3,000, which going into my budget of the machine, we'll probably go over entire budget and kind of what I got and what I got it for. That would have been more than 10% of my entire budget. Thankfully, I got this for about $2,000, and so it ended up being, yeah, I think it ended up being about 7% of my budget. I did budget for a phase converter. I budgeted $3,000 for one. I got it for 2. I got a good deal used. I still have to get it all wired and stuff, and that wiring and all that, because I have to run 4-gauge wire to it, is probably going to eat up $500. So I would probably get electrical done for $2,500, including a phase converter. So not too bad. Anyways, that'll be about 10% of my overall budget. I actually got a pretty good mill for a good price. I did it for 75% on budget, and then the last 25% of budget was for shipping, rigging, tooling, all that sort of stuff. So I got a great price on it. So let's go ahead and talk about what a phase converter is, why I need it, do you need it, and why three-phase is generally considered better, and why it's used for commercial machines and not residential or like garage shop sort of machines. Like why is the Tormach single phase, right? Why don't we have three-phase? What is three-phase? And then I can probably go into some of the very surface level math in it. I understand a very surface level of it, but I couldn't go in. I'm not an electrical engineer. I can't go in and tell you all this stuff. Let's go to a desk and explain some of that. I'll use a piece of paper and stuff. Okay, so I decided to redraw this. This is one period of a sine and cosine wave, and it's not enough to fully show it, so I'm gonna do more periods of the sine and cosine wave. So I'll have a period here and a period here. And for those of you who don't know, a period is just basically a sine wave does one full oscillation, if you will, within a singular period. And so the standard period for a sine wave would be like 2 pi, right? And you can stretch or condense it, so you could make it be a half period over 2 pi, or you could have 1 period over, well, that would be the same thing, or you could have 2 periods in 2 pi, so the period would become 1 pi, right? So there's different ways to mess with this. I'm just going to try and keep it simple and do standard periods. So this would be like 2 pi, 4 pi, 6 pi, 8 pi, right? That's not how you draw 8 pi. And so basically what we're gonna do is a sine wave starts at a minimum, and I just realized I drew my max is a little too tall for this, and we're gonna have a half period in between these. And then we have a quarter periods. So we have 4 positions, and so our top position is it's gonna reach its top at the quarter position, and then it's gonna come back down at the half position, and then it's gonna reach its minimum at the quarter position, and it's gonna come back up to this. This is 1 period of sine. And then we can repeat this again. We're gonna come up, and then the half position, come down, and then up. Anyways, you get the idea. This is wrong. Okay, so what is AC power? It turns off and on again, and off and on again, and off and on again. It's pulsing instead of DC, which would be a constant flat. It would be a constant line of you have this much power, you're gonna have a pulse. And so on, off, right? And what you can do is you can offset this by now putting in a cosine. So cosine starts at a max, whereas sine starts at a min. And you're gonna come down, if my pen will draw, and then we'll reach our min at this point, and then we're gonna come through here and up like this, and we're gonna start making these. I'm gonna get a graphing calculator. All right, so after trying to draw it on paper like 8 times, I decided to just grab a graphing calculator and show you sine. And so basically, so the peak of sine is on and then off and then on and then off, and what we can do is we can plug in offsets for this, and so we'll just plug in cos of x, and we can see that the off and on again now is a little staggered because we stagger our power, and so now we have it on and then on again, and then there's an off. And so what that third phase does is that fills in that gap. Now I don't actually know which one we're supposed to use because it's not tangent. We plug in tangent, and so somebody who knows a little more about 3 phases can tell me what we're supposed to be using here, because as you see, tangent is a different graph. It's not like this. It's different. Tangent is different. It's not the same thing. And so what it probably is we're probably just offsetting sine multiple times. And so if we delete this, okay, we're gonna clear this, and we're gonna clear this, and then we do sine. It would be x plus 1 divided by 3. And that should offset it by 1/3. Oh, whoops. Sine of x. This one should do it. There it is. No, that's wrong again. Well, I should have been right the first time. Because that's the y offset, and the x offset should be directly applied to the x. Don't do math for like 2 weeks and you forget everything. Okay, and then it's going to be x plus our period is 2 pi. That should give us our correct offset, if I'm not mistaken. Come on. Why is it tracing over the same graph again? Am I just... Yep, there it is. Oh my goodness. That is exactly what I wanted to do. I was doing it right. Mostly, I was mostly doing it right. I got it, I got there. Okay, so now that I'm in radians and not degrees, we can see that we can offset this by a third. And hey, look at that. We now have 2 ons. And then if we go here and we do this again, we do sine of x, which is what we're using. And then we're going to add 2/3 times 2 pi, because 2 pi is our period. It doesn't really matter to you. And now we can add our 3 phases. And we can see we go from on, off, on, off, on, off to essentially being all on. It actually kind of looks like a helix, which is kind of cool. So that is why 3 phases of power are important. And this is why being in the correct mode on your graphing calculator is important. That's the explanation on that. There's like 20 minutes of explanation there, and way too much of that was screwing with the calculator. So this is the phase converter, and it's quite large. It weighs, I believe the ticket was 290 pounds. So naturally I want to see if I can lift this. That's heavy. I'm going to check the video to make sure that came all the way up the ground in a minute, but that's not important. Got the motor on the pallet jack. It was way harder than it should have been. What we're gonna do is we're gonna put this over on the desk, kind of where it's gonna go, and then we'll open this up, look at this, make sure nothing got damaged in this during shipping. Let's go pick up that thing. There it is. There's that. So let's go ahead and get this front panel off. And basically what we're just gonna be looking for is making sure nothing is horribly messed up. Good now. Come off, and look at that. That is our phase converter, and it looks like, so now, these are all capacitors, which you really don't want to touch after it's been running. Now, this has not been powered for, assuming he had it running up until he shipped it, like 5 days. What looks like has happened is that the sticky pads on the back of these no longer have the stickies, and so these moved a little bit. I did feel something shifting in here and I was a little worried about it, but it looks like that's a little bent, but it doesn't look like it was broken. And everything else looks pretty good. That being said, this says here it's a 30 horsepower starter, so that's interesting. I'll have to look at the motor. I thought this was a 25, and it says ADU 25 on the front. So basically what we're looking at now is we're going to be looking at mounting points, which it'll be mounting right there. So we're going to mount this to the wall, and then what we're going to be running is we'll be running our wires to this. And so I'll pull out the wire. You can see the wiring diagram one. We have L1 input, and we have our outputs. It looks like right over there. So as a quick explanation, we're going to plug power in from our panel into here and here. And we're gonna have power coming out here and here. Those are 2 of our 3 phases. So we're gonna be pushing power through here, and that's gonna be connecting to our plug, which will go here. Our single phase goes in here. We have 2 lines of single phase, and then they get output here and here for the motor. This is the ground. And then we have our idler, our motor. Our motor gets powered from these 3 ports here. So power in, so it gets powered here and here, and then here as well. This is our artificial third leg. As you can see, there's 2. We plug power in here, and power comes out here. So this is what makes our 3rd phase. We run the motor on 2 phases. These capacitors are to start that 3-phase motor. And then once it's started, it's going to output a 3rd leg into here. And then we take our ports from this side and this side, combine them together, as well as our ground. And we have our 3-phase power with a ground leg. It's not super complicated, so I'm gonna go ahead and get this ready to go up on the wall. I'll probably move this bench out and do some cleaning, so let's do a time lapse for that. And then I'll map out, the wall's concrete, so I have to do concrete anchors, so it's kind of annoying, but we should be good. You're now segregated to this weird angle because this is where I have power and my charge is low. So the next step is basically gonna be, is I want the bottom of this converter aligned with this. This is easy with 2 people because someone can hold it and then mark the holes and then drill the holes and then put it back up and put a screw in. I'm the only one here right now, so I'm gonna have to get a little creative with stacking. So basically what the challenge is this is not super heavy, but it's kind of big and awkward, and it weighs, I don't know, probably 20 pounds. So the challenge here is I need to hold this like this and then mark where these holes are going. The plan has changed a little bit. Kind of what I am thinking is I want the top of this to be, or the bottom of this to be at 4 feet, which is right here, if you can see that. If we look at this plug, it's kind of towards the top of that plug. So that's what I wanted to do, is have the bottom aligned with this, but I think I'm gonna just have the bottom aligned with the top of this. And the reason why is I measured the cable coming out of the idler motor, and it's about 4 feet. It's 4 feet, it's about 10 inches off the ground, and it's got some extra to go into the panel, and so we have about 4 feet. The top of this is at, I think, almost 5 feet? Yeah, it's at 58 inches, 60 inches is 5 feet. So, at that point, it would have just been really tight for that wire, especially considering the motor is going to be off to the side, considering the table goes right here. So the wire is going to kind of curve up into here. Could it have been done? Yes, probably. But it's going to be much easier to do that, giving myself another 10 inches. And I won't have to worry about potentially having to rewire the idler, which is, if avoidable, something I want to do. We're just going to put it at the top of this. We should be totally clear on everything on the table. And we're just going to kind of put it right here next to that plug. So I kind of found something that I can use to put this on, and now this is the wrong height, so I need to find something else to do that. Ah, look at that. That is actually level, shockingly. So we have holes here, 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 and here. It's a concrete wall, so we need to use concrete anchors, which is both nice and really annoying at the same time. Okay, so now that these holes are in, we're going to do the same jank setup. Put the first screw in, maybe the first two. Well, first one, and then we'll put one in loose. Glad that ended up working out being level. So now that we have 2 screws in, go ahead and get this jank setup off. And we'll go ahead and put the rest of the screws in and then tighten them down. And that's level. Okay, so this is where it is on the wall, and we're gonna run power from that panel to here. So we're running power as little distance as is humanly possible, because we have to run 4 gauge on an 80 amp breaker for this, and so I don't want to run a fortune in wires. The next step is going to be getting the motor hooked up to this, and so I'm going to go ahead and do that. Realistically, what the next step should be is running power to this. I unfortunately don't have my wire or my conduit, and I don't currently have a vehicle which I can go get. So that's going to be done later. What I can do now is hook the motor up, as it's a pretty simple process and I have everything I need to do that. So the motor's going to go right here. So I'm going to go ahead and move some of this material and then get the motor set up. So this thing is just enormous. So I want this off right there. You can see that's about how much room we had for the cord. So that ended up being about perfect. It's almost like I measured it. Stop. Rubber feet are great at keeping it where it's supposed to be. Oh, wow, those are really good. Oh! Ow! That hurt. Ow, when I did this slid forward and just mangled my knuckle into that. Okay, so the red is going to go on the red, the blue is going to go on the blue, the black is going to go on the black, and the green is going to go on the ground, which is the green. Okay, so I can see the other wires sticking through this end, which means it's far enough in, and then I'm gonna give this a real good tightening. Just real solid, nice and tight. Okay, so that's in. And then we'll do the black one next. that, make sure everything's tight, it's not gonna move. That was a lot. By a lot, I mean, how long? 5 minutes, 10 minutes? Okay, so I'm not sure how much of that you watched because I spent a little while wiring it, but there is the idler motor and there is the actual unit. The shielding came apart on that a bit and I don't like that, so I'm not sure. I'm not going to rewire this. You can also see that this is not clamped. Yeah, I think what I'm probably gonna do is just get new shielding for this, get a longer piece of shielding because I have more wire and stuff like that. Re-shield this. I don't have to rewire that. I'll take it off from this end and just undo what I did there because that doesn't take super long. But right now, this is how it looks. Need to get the actual wiring for the panel. That's pretty simple. We'll just run some conduit up through here. And then what we do from here is just plug those into these two ports here and then a ground into the ground. And that's kind of it. And then we wire the plug. And so we'll put a plug here and we'll run wires to the plug, both here and here. And then that is it. Okay, it is in. Took a little while, mostly because I had to take the Z-axis motor off. I'll show you that in a second. And then it just clears the door right here, just barely. Just be very careful. And then when the actual spindle is all the way up, I think it would hit this door. And so it has to operate with the door down. And I'm gonna disconnect the door so that nobody can accidentally open it into the machine while the machine's running or while it's up. I did have to take this off. This goes right on top of here and it just sticks up an extra, I don't know, 7 inches or something. And that was just an inch too tall to clear this lip. Besides that, need power, need to level it, need to get all the coolant stuff plugged in and working. But that's not an absurd amount of work. It's not even sort of level. Like you can eyeball and see that this thing's crooked as sin. So I need to get it level. I need to get it powered. I need to get some other stuff in. I need to put the Z-axis motor back on because I had to take that off to get it in here. So there's there's still a lot of stuff to do, but hopefully I'll have it turned on and operational tomorrow. It won't be making parts yet. I still need to learn FANUC. And so there's a lot of stuff here. I might replace the acrylic on this sheet and the side sheet. I'll try cleaning these, and if it cleans up well, great, but it's 20 years old, so probably not. It's a little dirty. There's some just chips and stuff in here, so I'm gonna clean this out once we get everything running, and then also clean off some of this surface rust. It is pretty surface though. That wasn't there until that happened during shipping, unfortunately. So what are the next steps? So the next steps are get a level, put the Z-axis motor back on. Once that's back on, what I'm gonna do is I'm going to roughly level the machine. I can't fully level it until I'm able to jog the axes. And then when I get the rest of my stuff for power, finish wiring up the phase converter to get this thing plugged in. And then that's all I can do until we have it powered. And then once it's powered, make sure everything's running, stuff like that. And then actually start playing with it, or realistically learning FANUC, because I don't know how to do that. Yay, lots of work to do. Okay, let's do a time lapse of putting that motor back on. Okay, that is back on, and that took a blessedly short amount of time. It took the better part of an hour to get that off in the hot sun, and that went back on 5-10 minutes. It was really quick. So I guess the getting off part is difficult and not the putting it back on part is difficult. So next thing I'm gonna do is level the machine. So I can't fully level it, but I can kind of get there roughly. And the reason I can't fully level it is because I don't have this powered yet. And when you level the machine, you level the entire axis. And so you'll level it at one point, move the table forward, level it at that point, and then you kind of match it and then do the same on the Y, and then you kind of get everything as close as you can. But that's basically what I'm going to be doing. So I'll put you on a tripod and I'll just start leveling things. I'm going to start with just a carpenter's level because this is just really far off. And then I'll pull in the machine level when it's done, because I do have a specific level for leveling machines that's way more precise than a carpenter's level. So start with the carpenter's level, move to the machine level. Okay, so this is a little too high. All right, that's where it goes up, and I don't know if you can see it. So this end needs to go down. And so what we're gonna do is we're gonna go to a level of feet here. And these have leveling, and basically we're just going to loosen these. And it's going to move down. And then once this reaches a position where it's level, we're good to go. I'm going to go to the other side and continue this because I already know both of these are too tall. Basically what's going to happen is we're going to get it level in this direction, and then when we get it level this direction, we're going to end up messing this up, and so we have to do it like a couple times to get it there. There's probably a more efficient way to step it in. I don't know that. I'm just going to go the brute force method, get a carpenter level, go to the machine level, and tune that in. And then when we get power, finish tuning it in. What I'll do after I get this basically in is clean this. I took those doors off, I'll clean those. And then after this gets level, there's not a ton for me to do without power. So just hope that those come in pretty soon. It's 2 o'clock, so I don't know. They might be here in the next couple hours, in which case that would be pretty good timing. So, yep. Let's switch to the time lapse so you don't need to watch all this. Okay, so I got it roughly level with the carpenter's level. You can see that that is level there, and then same goes for there. Roughly level. There's still like pitting and stuff on the table that's gonna mess up my machine level, so I'm gonna go ahead and start now. Okay, I'm actually gonna start with the steel wool and just kind of see what happens here. Okay, that's a pretty good start. I mean, if I can put this in frame, it's getting all the surface level stuff off. And then if I grab a paper towel, which I've been throwing my dirty ones just in here from the top, that's a good start. It's not perfectly flat, so I will stone this when I'm done, but that deals with the rust. So, okay, let's go ahead and start doing that. Okay, so that is much better. It's not perfect, but that's a good start. So let's go ahead and clean those covers, and then I guess just continue cleaning. Okay, it is the next morning, and I did get power to this last night. I am having some issues, and one of the things to resolve the issues was just like, hey, let it sit for a little while. So I let it sit all night. So let's go ahead and power this thing on. Phase converter works. Plug our air in, which does have a small leak down here, so that needs to get fixed. Okay, so we do have power to it, which is a good start, but you're gonna see, assuming that the error persists, what the error is, and then kind of how I plan to go about troubleshooting that. Yep, so here it is. So I am having cooling fan failures for some reason. I don't know why, and I can't just reset out of it. So if I go to reset, it's not resetting out of it. It won't let me reset out of the e-stop, which this should do. I talked to the previous owner, and he was like, yeah, I've never seen this before. So, yeah, my favorite thing ever to deal with stuff like this. And you can see here I'm still e-stopped, even though I'm not e-stopped, and I can't reset anything, so yay. Okay, so basically how I want to go about troubleshooting this is I just unplug the machine, and I'm gonna open up the garage door and get back in that panel. Is I don't think every single cooling fan on this machine died at the same time. So the cooling fans are all connected to each other somehow, and so they're all in the drives, and when I open that up, you'll see the drives for this machine. I watched a video talking about the fans and the fan issues, and so I'm going to get this opened in a minute, and the cooling fans are kind of like right here, and they're in this back panel, and so what I'm gonna need to do is get that open, check the fans themselves, make sure there's nothing blocking them or something like that. Maybe something moved during shipping. What probably happened is some wire back there got unplugged during shipping. And that's just not giving the signal to the machine that the fans are okay, or they're not powered or something. that is everything. Now down here we have these plugs. So this is U4, V4, W4, US, VS, WS. There's a ground. These are bigger plugs. We got X-axis and Y-axis plug. This is heavy. Those are nasty. So that's good. By good, I mean bad, but something's obviously messed up with that. That was a lot. That's heavy. So, all right, so I've got the drives, and you can see I have some fans here and here, just in the top of these. And if I blow on those, they spin freely. Don't even attempt to move. These are pretty nasty. The actual rest of the box here is really clean, and so I'm unsure as to why just these are covered in shmoo. Sometimes what happens is during shipping, coolant shmoo gets way worse. I've had this happen before. Either that or the previous owner was lying about these not working, which I saw the machine running, so I'm assuming he wasn't. But in video I saw it running. So, I'm just going to assume that he was telling the truth and that this just got worse during shipping because of all the different climate changes and stuff that it doesn't usually go through. Got this clean. It is not the smoothest fan in the world by anywhere near, and I can feel bad bearings, but hopefully this is enough to just get it to run. It does now spin though. So don't love it, but this is the best chance we're gonna have at getting these to run without replacing them. Okay, it is 10:30. I have got everything back in and back wired. I'm pretty sure this is all correct. I got all my grounds in. Yep, and so I followed my video I took and I plugged everything back in and everything seems to have gone well. And so I'm going to close this up. I really hope this works, because if it doesn't, I really don't have any idea. All right, power's on, that's a start. Man, I really hope this works. If this doesn't work, I don't know what. I do feel some air moving. Okay, that's good, that's good. It's a different alarm. Number of amps is small. K8 relay is defective. Okay, these are new error codes, which is good. Can I reset this? Why? Okay, well, that's probably something I plugged in wrong. I don't know what that would be, and then I don't know what that is. But they're not the same. Oh my goodness, I'm gonna lose my mind. Well, I guess it's progress. I don't know, not that much progress, but it's progress. Okay, quick update. I kind of forgot to keep y'all updated. It's working. As you can see from the coolant and stuff like this, I did get it working. Okay, while this is booting up, we could kind of go over some of the stuff. So I need to put this panel back on and I'm gonna replace these fans. I have new ones coming, I'm gonna replace them. I got the coolant system working. It does not have a filter. I'm going to add a filter and then I need to fix the air leak and stuff like that. So I'll be working on that over the next week. So for some reason, my x-axis is backwards. When I go plus, it goes minus, look. Weird. The y-axis is fine. If I go minus, it goes minus. And the z-axis is fine. But that's weird. Okay, so let's do a tool change. So how do we do a tool change? Well, I'm glad you asked. We have tool 1 in the spindle right now, and we're going to be going to tool 4 because that's the only other one currently in here. So we're in our menu here, and so we're going to go to tool 1. And so we press 1 input, and then we have our tool code. So that's going to be tool 4 input. Okay, and then we're going to press this button here. And then we're going to turn our rapid to 100%, press start. And that is the tool change. And we also got like coolant working. So if we want to run coolant, we got coolant. So yeah, pretty cool. Okay, so it is time for first chips on the robo drill. So kind of what the first step is going to be is to get the vise in. And that's the first hurdle. So the table uses these T-nuts. These are pretty just standard size T-nuts. There's a small size T-nut and a large size T-nut. So here are all the T-nuts I have. I have 2 of these T-nuts. I usually put 3 on the vise. Now I can get away with 2, especially because I'm gonna be doing really light cutting. So I went ahead and ordered some of these. They'll be here tomorrow. But that was just one of the first things. I was like, I wouldn't be able to use this mill if the spindle brace, if he didn't use T-nuts to fixture down his spindle brace when he shipped it. So thank goodness for that. I got the mill on, and what we're gonna have to do is we're gonna have to tram in the vise. So I'm gonna take my Heimer, because this doesn't have a probe or anything like that. And so we need to use a Heimer. Now we have the Heimer in the mill. And the Heimer, for those of you who don't know, is just a measuring tool. So we're gonna jog it down. All right, so we're gonna set this to 0 basically. See, look at that. Bring it to our 0 mark right there. Boom, 0. So now we're gonna go to our X. And we're gonna sweep this across. So you can see it's going that way. And we're just gonna tap this in. It has a little bit of movement in there, but it's nothing absurd. So let's tighten this. And let's get this back to our 0 point. And let's sweep this across. Alright, so there is a tiny bit of run out here. So we're gonna just tap this over a little bit. Put it over the other way. And tighten this. Not absolutely perfect, but it's pretty good. So that is a good start. All right, now comes the rest of it that I don't really know how to do on this machine. All right, so the next part's gonna be a bit of a learning curve for me. And what I mean by a bit is quite a lot. So I need to set my tool offsets. And so you can see my offset settings here. And so I need to figure out how to set these. And so I need to set my Z offset up here. I need to set my ZX and Y offset. I'm gonna be measuring off the top corner piece of material here. And so I need to figure out how to get all that set. And I also need to set the Heimer length. And I'm gonna do that off of this on a kite setter. So let's go ahead. And I'm gonna do some of that without filming just so that I can concentrate. Okay, so I got my tool heights set. It's not a super complicated process. I just wanted to be kind of careful when doing it. So basically you come over to this page and we go to offset tools. And this page and we choose our tool number. So this is, well, that's tool 200 because that's my max tool number, right? And we can go to say 200 here. And then if I wanted to reset this, what I'd do is I'd press Z and then it would give me options, and then I could do input C, but I'm not going to do that because I don't want to. I don't want to mess with my tool height there. And so basically what that tool height is I measured the top of the spindle to the bottom of this, and you can see where it left some schmoo there. And then this platform here is flat with this. And so I took my Heimer and I zeroed it out on there, and that gives me my 0 distance from the spindle to the Heimer. And then that's measuring the Heimer, which I can use that measurement forever, basically. And then I did the same thing with this, which is tool 25. We should be good to go there. Now, basically what I need to do is use the Heimer to measure my workpiece. Okay, so I just spent the last hour and a half figuring out how to load a program from that flashcard onto here, as well as figure out, because I was using tool 25 in my program, and there was tool 4 in there, and so I had to figure out why in the world that was in there. Also, I finished running the program and it auto shut off my deli roll whopper. Like, what's that about? Once I have my program here, I'm going to go to the graph screen. And then once I'm in the graph screen, I can execute. Let's make sure this is closed. I can execute. It wants me to change memory mode. Okay, execute. And then it's going to register this out. And I can go ahead and start it. Oh, that is unnervingly quick. So yeah, and then I'll just double the feed rate. So yeah, this is kind of insane. That's 25% rapids, by the way. I'm gonna do this at 100 on the next one, just because I wanted to test this out first. That coolant is a little much. That's just facing off this block, and it didn't even take a cut. I'm gonna run this again really quick at 100% rapids. Oh my goodness. Okay, you ready? I'm gonna keep the door closed because I'm still scared of it, but let's just see how quick this goes. Oh, my heart left my body. Okay, so that was a cool test program. Now I'm going to load one of the actual programs I'm gonna use. And by load, I mean I'm actually going to write it for this machine, and I need to solve a couple issues like not being able to go past tool 14. What I did is I kind of just told it in the program, hey, this is tool 4, use height offset 25, because it's gonna be tool 25 and that's the height offset. Okay, quick question for anybody who knows stuff about FANUC, whatever. Is there a way in the program, in this machine, to tell it, hey, I put tool 20 into tool changer position 4. When the program calls for tool 20, it's in position 4. Because with all the stuff I've been doing, when I try to tool change to tool 20, it tells me error, ATC error, because the ATC only goes up to tool 14. And so basically what the mill wants to do is it wants to say, hey, position number 4 is tool number 4. And position number 5 is tool number 5. And so if my program uses any tools outside of 1 through 14, it doesn't work because it tool changes to tool 1 through 14 and nothing else. So from what I understand, there's no way to say, hey, I put tool 20 in position 4 when the program calls for that tool change to position 4 because tool 20 is in there. Is there a way to do that?